Basically, I'm a civil environmental engineer. Did my bachelor's in environmental engineering from Shivaji University, Kolhapur, and then did my master's in environmental engineering from VJTI, Mumbai. And then I worked in industry for some time as a design engineer. And then I came for a PhD at IIT Bombay in Center for Environmental Science and Engineering, uh, where I worked with Professor Asolekar and Professor Shubhankar Karmakar, and I worked on wastewater treatment technology selection. And then again, I worked for industry in another 2 years, and then went for a postdoc in Technical University of Denmark
Right.
on with the Marie Curie fellowship. And then then I came back to Center for Environmental Urban Science and Engineering from November 2016. So almost 4 years I'm going to complete in this
Great.
field.
Yeah. Thank you. So, Kalbar, we have got 15 minutes total, of which you got 12 minutes of presentation and 3 minutes for question answer. After
Yeah.
10 minutes, I'll give you some hint that 2 minutes are remaining, and then we can keep 3 minutes for question answer session.
Yeah.
And all the questions will be taken from the chat box, or if allowed, then if there is no noise, we can take it on the mic also. Please go ahead.
Yes. Thank you. First, I would like to thank you IRCC and the selection committee for selecting me for this particular award. And I chosen one specific topic, but I would little bit give overview of the work that I have been conducting in CUs for last 4 years. So basically, my research areas focus on urban water supply, basically network improvements, what are the ground reality, and how we can improve that. So a lot of students and staff are working on that. Then wastewater management, where how to select a better technology for different urban, rural, peri-urban settings, and techno-economic assessments related to that, and how we can adopt those technologies for better results. And then climate change mitigation, how we can, what are the different strategies for different sectors we can apply for climate change mitigation, and sustainability, overall sustainability assessment. So these are the four broad areas, thrust areas my research group is focusing on. uh, so I will briefly explain one of a few of the topics that I have been working. So the recent work which is completed is about development of a framework and methodology for quantitative sustainability assessment. So basically, in this field, there was a lot of gap with respect to a holistic methodology for assessing sustainability of the products and technologies. So with my collaboration with Professor Monier Nero from Aalborg University, Denmark, we developed and proposed one methodology for assessing sustainability of the products. And this particular work received a recently Prisma Award, which is given for groundbreaking research on sustainability assessment and policy. So this is the publication for which this award was given in resource conservation and recycling. And then I also recently applied the improved this framework for selecting the appropriate location with the help of Vinay Yadav, who was a PhD student with Professor Karmakar and Professor Dikshit in CAC. And in book chapter, I documented the entire framework with my PhD student as Deep Jyoti Das, who is currently working with me. Uh, the next piece of work is on quantitative approach for urban coastal areas classification. So in India, there is a prevailing regulation of coastal regulation zones, which is a policy regulation by which the lands are classified. But that particular framework had a lot of subjectivity and it lacked the basically scientific principles. So with Ravinder Dhiman, who has graduated recently, and Professor Inamdar was a co-supervisor, we developed a GIS coupled multi-criteria decision-making framework for classifying urban coastal areas. And this particular methodology will be very useful in protection of coasts in urban areas in India. So these two publications are outcome of this work, and some are under review. And this particular student's work has received Excellence in PhD Thesis Award for this year. Then I have these ongoing works which are one of the student Nikita Kakwani. She is working on circular economy of urban water sector in India, because particularly for this wastewater sanitation sector, technology is not an issue. The appropriate technology for a particular location, particular setting is more important. And circular economy helps in basically uh, providing some impetus for adoption of these technologies. So whatever policy gap, whatever other management kind of support is needed. So circular economy provides that kind of framework. So basically, first we reviewed the terminologies, reviewed the entire literature, what who in worldwide what is happening in this particular sector, and Nikita in her third year has published this particular comprehensive review about circular economy in urban water sector, where we have documented challenges and opportunities. We have proposed such kind of framework of defining what is basically reuse, recycle, because a lot of ambiguity in the terms were also observed. So it is the work is in progress, and now she will be actually quantifying the circular economy, for, at least in urban water sector for cities in India. So a few case studies we are working on. So in this direction, I have a collaboration and a project funded by Department of Science and Technology, which is a 5-year long innovation center, virtual innovation center that they have funded with NIH Roorkee, CU's IIT Bombay, MNIT, and IRMA Gujarat. And here, what we are going to do is basically develop a decision support tool for selecting the natural treatment systems, which are not energy intensive, but how we can promote these technologies, how we can create suitable business models and surrounding situations. So it's a technology package development and a decision support tool development 5-year long project that we are working on. So this is one theme of the work. Another theme of work is environmental assessment of urban passenger transportation. So again, I have a collaboration with Professor Nagendra Velga from Civil Engineering Transportation Group, and Deepjyoti Das is a PhD student working on methodology development and systems modeling. So we are basically assessing what we need to do, whatever the proposed interventions such as e-vehicles, car sharing models, with how they will impact how they will basically change the environmental impact of passenger transport, whether it will increase, whether it will decrease, whether that will be sufficient to meet the global and national commitments of climate change. So that particular angle we are investigating. So these publications are under review, and this student is basically soon going to conclude this work. Uh, and the final, the major work area that is I'm working is alternate design and operational strategies for improving water supply systems in India. So basically, this particular water supply system in India is a very multi-dimensional problem, not only from technology but how, because uh, tariff, consumers, government bodies, all are involved, and this basically many in none of city we are having continuous 24 by 7 water supply, which is a ideal objective. All developing countries have that, but why we are not able to achieve that, and how we can first improve the ground reality. That's what this particular topic I'm working on. So basically, whatever solutions industry gives are not suitable for the Indian conditions. They come from some Western or some developed countries context, and they just try to impose on our government. And in this context, based on my industry experience, field work, and research, I have proposed some low-cost interventions for improving this. And two students, Anuj and Abhishek, where Professor Daman is also involved, are basically working and helping me a lot towards this direction. And these interventions recommended by me are basically adopted by Ministry of Jal Shakti, and asked all the states to look into and implement those interventions. So basically, I will just in a brief, I will explain what is exactly we are trying to do. So actual field condition is that all this for any given city, a small zone in a city, entire mixed water network is there, and tracing that network itself is a challenge. All the storage tanks and reservoirs are placed at one location, that creates another complexity. So there are no distinct zones or subzones formed, and water distribution systems emerging from all the tanks are interconnected. So there is no mapping, there is no scientific isolation for the this particular pipeline, no control on withdrawal. So whatever design theory is there, that we consumers will consume some definite volume of the water, that doesn't work out on the ground. Everyone is basically have open taps, open storages. So as soon as water is supplied, it is consumed. So it is practice to divide the city in different zones by controlling walls and bifurcating supply times. And we are trapped in a vicious cycle because there is no service, there is no money, so there is no money for maintenance, so consumers are not willing to pay. So this particular vicious cycle we are trapped in, and basically we are developing solutions to come out of this particular vicious, whether it is rural, peri-urban, or urban, everything is every urban local body is facing the same problem. The major issues that we are addressing is how we can develop a suitable hydraulic modeling techniques, because that is a big gap. The models that are applied modeling procedures are not relevant for Indian conditions. Planning and designs are not suitable for Indian conditions. We have issue of large scale infrastructure, uncontrolled withdrawal, unequal pressure, leakages, operational issues. So my research group is focusing on this. So basically, what we are proposing is to have a small scale decentralized infrastructure. So instead of having very large centralized tanks, we can have a small
Professor,
tank.
last 2 minutes, huh, Professor Kalbar.
Yeah, thank you. We have these multi-outlet tanks, and we have proposed this as one of the strategy for this improvement. And then we propose to have this for urban or peri-urban or rural schemes, so that these distinct design zones can be achieved. And we have shown the hydraulic improvement using particular modeling techniques, how we can how this multi-outlet system is better than single outlet system, which doesn't cost any nothing. It's just a change of design practice. And we are also proposing some shaft kind of intervention to replace the storage tanks which are leaking, which are old. So shaft is this kind of structure, and we are demonstrating it in actually Palghar, the district in Safale, which is actually a urban reality. Although it is a gram panchayat, but it's an urban setting. And we had various meetings and workshop with them, understood their challenges. My four project staff, two PhD students stay there. We have flat there, so all the staff is deputed there. We have multiple meetings with these people, stakeholders. We conduct a lot of sampling. We entirely documented and mapped the entire area, and now we are actually demonstrating with DST funding. We have actually constructed this shaft, and this is now going to be completed in coming 2 weeks. And this is funded by Department of Science and Technology. And another project I have received for the extension of this work for sanitation and water supply in the second tier cities. So this is the all these recommendations are from Jal Shakti Ministry are adopted, and I'm working with state governments to complete these demonstrations. So I would like to acknowledge the students. All students are really. I'm very fortunate to have to this wonderful team, all faculty colleagues and current and previous years of CUs. These faculty collaborators on campus and external collaborators, and very generous funding received by DST through three large-scale projects. Thank you.